Okay guys, a really quick video on a lifter and how it works. This is an old school lifter, sits in a board, a cam rides underneath it. Cam is cut on an angle so the lifter is always turning, and that angle also keeps the cam pushed back in the block so it doesn't walk forward. Rides on the thrust on the back of the timing chain gear. This hole here, where are they? Right here, this hole here is the charging hole. Okay, when your valve is closed, oil flows in here, goes up through the center, and goes up your push rod. That's when you prime your motor, you see oil come up. Okay, this spring is what adjusts as your valves wear and the cam wears. This is what takes up the difference. That little spring right there, that's all that spring does. That keeps this pushed up against everything. The oil does not pump up your lifters. The oil just gets trapped in your lifters. So the oil comes in the hole, right? There's another hole on the other side. It flows through to the lifter bore, comes up your push rod. As soon as this thing lifts, okay, this pushes down. When this pushes down, the inside down here, there's a little check valve or a ball. So as soon as it does that and goes like this, it's hydrolocked. It goes up, it opens your valve, comes back down, the pressure releases, oil flows through it again, comes up, oil gets trapped, and that's how the lifter works. Okay? It never puts oil in there and lifts the plunger. That's not the way it works. The spring is what does that. Okay, so inside here, here's your little seat, and you see your little hole, that's where your push rod sits. Deep down in there in the bottom, you're never going to make it out in this light. And here is a check valve. When you don't change your oil and you get sludge in the bottom of your lifter like this one has, this check valve doesn't seal. Car goes down the road ticking. Tick, 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 tick. Does ticking hurt the performance? Absolutely. It will be noticeable? I'm not sure. I don't know if anybody's that good. Because the bottom line is, this lifter is constantly hitting the floor. That's what the tick is. So the oil goes in, goes up the push rod. When the lifter goes to go up, this can't seal, so it hits the bottom. It's like you hitting the bottom of your pool when you jump in instead of floating. So it hits the bottom, then it closes or opens your valves. Comes back down, it lifts up, the oil flows through, it goes to do it again, this slams on the bottom, and that's your ticket. So when people, you see them put Marvel Mr. Oil in, people used to put Dextron in the car, they would put a half a quart in when they did an oil change. It actually can loosen this garbage up, depending on how much is there. And the lifters can start, or stop ticking again. We just had a door open up from wind. So, just figured I'd show you guys that. Obviously, if this bore wears and there's scratches in it, when you go to lift the push rod, obviously oil is going to leak by. It's going to be the same thing as bad rings. Okay, there's a lot of things that could fail. Like this one here, you can see it's sunken in. Not supposed to be sunken in. So that's in a nutshell. And this thing sits in there. It's actually a tiny little gasket that sits there. And that's your lift in a nutshell. I've seen these lifters when a valve makes contact with a piston and this thing can't go up. The bottom of this is very, very thin and it's cast iron. And the cam just goes boop, and pushes the center in like a tin can and blows out the bottom of the lifter. So if you ever have contact, always pull your lifters out, and you're better off just throwing them out right at that point. Because if you don't see the crack in it because it's smeared over, it will fail on you. I had a lifter split in half and stay in the bore fully intact, and I had no idea. So with that said, guys, that's like lifters 101, and they call it a lifter because it lifts. On an overhead engine, it's called a valve. It's a lash adjuster because it doesn't move. The rocker arm sits on it, and the cam usually pushes down on it, and it goes like this, and then the plunger will actually come up to make the difference here. So it actually, the plunger sticks out and it rises up instead of it going up and down in a bore. And those are the same thing. They're susceptible to sludging. The bore starting to wallow out, and the oil winging past it like that, that becomes a major problem. So, okie doke, guys. Let's get working. One last thing I didn't mention. When you guys put an engine together, and you put your push rods in and you turn your rocket nut half turn, some a 3/4 turn, some Fords and some AMCs, you just do it till it bottoms out, the actual nut on the stud. What you're doing is you are taking this plunger, and it's called mid-seating. You don't want it all the way at the top, and you don't want it buried at the bottom. You need it to be able to take up differences from heat, from wear, so you mid-seat it, and that's actually what you're doing. So if you went a half a turn, you went 3/4 of a turn, unless it bottoms out or hits the top, the motor will run exactly the same, unless you do it while it's running. And the reason when you're adjusting valves when it's running that it starts to run like crap is you're actually holding the valves open, because this is doing what we explained, and then all of a sudden you're pushing more on the push rod, and it can't adjust quick enough, so that valve never closes. So as you're working on it, you're doing it starts to run like crap, and all of a sudden it smooths out, and you say, oh, okay, I got the valve adjustment right. You had it right before you did that. So, and the reason some are half turn, some are 3/4 turn, you gotta look at the rocker arm ratios. The ratio has a big difference when you tighten the nut. If it's a 1.5 and a 1.7, 1.7 is gonna push the push rod down further, so usually the adjustment's smaller. So, and I do it a little different than other people. Most people, I put them in dry. I still see no reason why to lubricate these, because you put them in dry, you put your push rod in, you tighten your rocket till you go like this, and you just feel resistance to this push, and you can tell it's there. Okay, then you do your half turn, 3/4 turn, whatever it is. Then when you prime the engine, the lifter fills up. It prevents me from doing it and doing that half a turn or 3/4 of a turn, this thing staying locked, and me bending a valve because I have a piston up. Seen it, seen it, seen it, seen it, seen it.